everyone. Today we're going to continue on with chapter 5, and we're going to specifically talk about joints. Now, a lot of words in this section is really hard for me to pronounce, so please bear with me as I try to say some of these words. Joints are also called articulations. And so if you ever hear me talking about something articulating or articulations, I'm talking about joints. It's defined as a place where two or more bones meet, and every single bone in our body except for one is going to form a joint with another bone. Now, that one bone is called the hyoid bone. And since we haven't covered gross anatomy of bones, I just want to point out your hyoid bone is actually up here in your neck. So, this is your hyoid bone. It's not going to articulate with any other bones. It's kind of held in place by tissues and muscles around it. Now, the functions of joints is to hold bones together securely, but also allow for mobility for us to move. We have our elbow joint to bend our elbow, our knee joint to bend our knee. Now, there are two ways that we can classify joints. So I'm going to talk about each of these two ways. First, we're going to talk about functionality, or the amount of movement that that joint allows. Function. Does it allow little movement or a lot of movement? And then we're going to classify it structurally, which means what's its structure, what it's made up of. So what separates the bony regions at the joint? So first we're going to talk about functional classification. These focuses on the amount of movement that the joint allows. So synarthroses, these are called immovable joints. So these don't like to move, and these are typically going to be restricted to our axial skeleton. Now remember, our axial skeleton is going to be the main portion of our body. So it includes our skull, basically any region in our chest, and then also our cavity and our spine, our backbone. Amphiarthroses, these are slightly movable joints, so they do have a little bit more freedom, but they're still restricted to our axial skeleton. And then we have diarthroses. I always think of di meaning two. These are going to be freely movable, and this is predominant in our limbs. It makes sense because most of our movement takes place in our arms and our legs. Next, we're going to talk about the structural classification of bones. This is based on what actually separates the bony regions at a joint. Does fibrous tissue separate it, cartilage, or a joint cavity? If fibrous tissue separates, they're called fibrous joints, and most of these are immovable. They don't like to move. Cartilaginous joints, these are going to be separated by cartilage. These can be immovable, but some of them are slightly movable. Most of them are amphiarthrotic, which means slightly movable. And then synovial joints. These are our freely movable joints that typically take place in our knees or in our shoulders, etc. So let's separate this structural classification. We're going to first talk about fibrous joints. These, again, are united by fibrous tissue. There are three types that we're going to talk about. First is sutures, and this is actually going to be important on the second half of learning about bones. These are found in the skull. They hold the bones of the skull together, and they're immovable. So if I look at this, this is an example of a suture in your skull. And I've posted a picture. The skull is not one piece. It's a bunch of different bones together. So usually if you see lines like this or over here, those are called sutures. Then you have syndesmoses. These allow for a little bit more movement than sutures, but they're still considered immobile. They're found at the distal ends of your tibia and fibula. Now, we haven't learned your bones, so these are all in your lower leg. And in fact, your tibia is your shin. So if I look at this, here is your tibia, your shin, and then your fibula is this side bone over here. Down here near your ankle where they're connected, that's a fibrous connective tissue classified as a syndesmosis. And the last one is gomphoses. This is called a peg and socket joint. These are immobile, and these are going to be found where your teeth meet your facial bones. So if you look at it down here, you have your jaw, your upper and lower jaw. Your teeth actually are embedded in that bone, and that's a gomphoses joint. I think of gomphoses like gum. Teeth are embedded in your gums. Next, we're going to talk about cartilaginous joints. These bones come in two varieties, and they're classified based on the type of cartilage they have, whether you have hyaline cartilage versus fibrocartilage. Synchondroses is hyaline cartilage. These are immobile, and these are found in the epiphyseal plates on your long bones. And then sometimes they can be in between the joints of your ribs 1 through 7 and your sternum. Now, you don't know your sternum, but this is your breastbone right in the middle of your chest. So if you were going to look at it, here is your sternum right here in the middle of your chest, and it's going to link the different ribs here. So you have hyaline cartilage there. Then you have symphysis. This is linked by fibrocartilage. These are going to be slightly movable or functionally classified as amphiarthrotic. These are going to be found in your pubic symphysis, hence the word symphysis, or intervertebral discs. You are not sure where those are at, so let's actually give you a picture. Here is your pubic I think that's on the next line. Here is your pubic symphysis. It connects the two halves of your pubic bone together. And then here we have our intervertebral discs. These are bits of cartilage that's located in between your vertebrae and your backbone. So it cushions those. And the last one, which is the synovial joints, this is the biggest category of joints. These are separated by a joint cavity filled with synovial fluid. Now, synovial fluid, the whole function of this is to prevent / reduce friction in joints. There are 4 distinguishing features. First, articular cartilage. They cover the end of the bones that form joints. So we have mentioned articular cartilage before, found at the end of long bones. Then we have articular capsule, and this is where it's enclosed in this fibrous connective tissue, and it helps line and smooth out that membrane. Then that entire thing is surrounded by a joint cavity. Again, this contains synovial fluid, and it's lubricating, otherwise known as reducing friction. And all of this is reinforced by ligaments. So if you have your knee, you might have heard the terms ACL. Some people tear that, and it can be quite painful. The following are not strictly parts of the synovial joints, but they are often found closely associated with them. And the following are essentially basically bags of lubricants that help cushion and reduce friction between adjacent structures whenever that joint is moving. So you might have heard the term bursae. These are flattened fibrous sacs. These are located around synovial membranes, and they're filled with synovial fluid. They're common wherever ligaments, muscles, skin, tendons, or bones rub together. And then we have tendon sheaths. These are just elongated bursae or bursa, and these wrap around a tendon. So over here, this is a pretty good picture that your book gives of your synovial joint. So here's an example of a bursa. So it's not actually part of this joint here. It's kind of a cushion sac full of synovial fluid, and it helps prevent these ligaments from rubbing. Instead, you have the articular cartilage, and then you have everything that keeps surrounding it. Now, with synovial joints, we're going to talk about specific ones. First, I want to talk about multiaxial joints versus biaxial, etc. Multiaxial joints, these are going to allow us to move among multiple axes. So if you think about your shoulder, you can spin it around, move it every which way. It goes in circles, left to right, up, down, etc. Then we have something called uniaxial joints. These only allow you to move one way. So if you think about your elbow, it's a hinge joint. You can pull your elbow up and you can pull your elbow down, but you can't move it left to right or spin it in circles. And the last one is biaxial joints. Bi meaning two. These kind of allow you to move your hand up and down and left to right, but not much more than that. So the type of synovial joints is based on shape, which determines the movement that's allowed. So we're going to talk about, I believe, 6 of them. First one we're going to define as a plane joint. These are articular surfaces that are flat, hence the word plane. So Illinois is a plane, it's very flat. These are short slipping or sliding movements are allowed, and some examples of this are intercarpal joints in your wrist. So carpal just means the joints in your wrist. So I would just focus on this. If you were to look at a plane joint, notice here they are flat. We can slide left to right. And here is where they're talking about. This is your wrist or your hand movement, and it kind of allows those to slide. Next, we have a hinge joint, and exactly what it sounds like, a hinge of a door. The shape is more cylindrical end and of one bone fits into a trough shape of another bone. And angular movement is allowed in just one plane, kind of like a door. So its movement is considered uniaxial because it can only move in one axis. Some examples, things like this, are your elbow, ankle moves up and down, joints between your phalanges, which are your fingers. So here is an example of your hinge joint. So here is your trough, and your cylindrical surface kind of fits right in there. The next two we're going to talk about is your pivot joint and your condylar joint. Pivot, exactly what it sounds like. You're pivoting kind of like in basketball. This is where a rounded end of one bone fits into the ring or sleeve of another. It is uniaxial. And an example of where it's located, I'll show you, is your radial ulnar joint. You don't know what your radius ulnar joint is, but this is going to be in your forearm where your radius and ulna join. Or it's the joint between your atlas and axis, and you don't know what this is, so I would fill it in. These are your first 2 vertebrae in your back. So let's kind of show you an example of this. Here is your radius and ulna in your bone. Here is your pivot joint. So if you think about it, you can twist your arm left to right and have your palms face forward or backwards because of this pivot joint right here. Here, and then we can talk about condylar joint. This is an egg-shaped surface of one bone fits into kind of a little oval-shaped concave of another. Movement can occur side to side and back and forth, but it cannot rotate around a long axis or spin, so it's considered biaxial. Your knuckles are very good examples of these. So if we look at it, here are your knuckle joints. So this is a knuckle in your finger. You kind of just fit it in there. You can move it up and down, left to right for your finger. And then the last two are saddle joints and then ball and socket. Saddle joints is where both of the surfaces are convex and concave. So you have concave, it goes in, and convex goes out. These kind of have the same movement as condylar joints, and so they're going to be found in a lot of finger joints. So carpal metacarpal joints, you don't really have to know that, but just know they're kind of like in your thumb. Ball and socket joints, these are the most familiar. So let me go and give you an example of a saddle joint first. Here is your convex, and then here is your concave side. Here's your convex, and here's your concave side, and they kind of just sit in one another like a saddle. So here's an example of where this happens in your hand. And the last one is ball and socket. I started this one because this is the most familiar for you guys, and I know for a fact I'll ask it on your test. This is where you have a spherical or rounded head of one bone fits into the socket of another. And this is really the only one that's multi-axial. This allows movement around all areas of axes. And shoulders and hips are the biggest examples. Think about it. You can take your shoulder and wind it around like a softball pitch. You can take your hip and your leg and rotate it forward, back, left, right, or in a circle. So these are ball and socket joints. So when you think of it, exactly what it sounds like. Here's your ball fitting into a socket. You can go left to right, back and forth, around in a circle. And that's the end of today's lesson. If you have any questions, please make sure you ask. And otherwise, hope you have a great day.